Hi, hello everybody. In this video, I am going to discuss about quadratic functions. If you like this video, please share and subscribe and watch till to end. Please subscribe this video and encourage me to make more videos for you. Okay? And it is a very important concept, especially for JEE mains and advanced aspirants. Direct or indirect, we can expect so many questions based on quadratic function. Okay, here we have to learn about what is a quadratic function and how to draw its graphs, and what are the minimum and maximum values, and what are the types of graphs of quadratic functions. Okay, let us see. F of x is equals to ax square plus bx plus c, where a is not equals to 0, and a comma b comma c are complex numbers, is called a quadratic function. And we can also take, instead of f of x is y is equals to ax square plus bx plus c, and also y by a is equals to x square plus b by ax plus c by a, which is nothing but x plus b by 2a whole square, making it is perfect square, minus b square by 4a square plus c by a is equals to y by a. Can also be written as x plus b by 2a whole square, which is equals to b square by 4a square minus c by a plus y by a. Of course, this can be written as x plus b by 2a whole square y by a plus, by taking LCM here, b square minus 4ac by 4a square. So, which is nothing but 1 by a taken out common, y plus b square minus 4ac by 4a. Left hand side, it can also be written as x minus of minus b by 2a whole square, which is equals to 1 by a times y minus of 4ac minus b square by 4a, by taking common minus from b square minus 4ac. Observe that the equation is in the form of x minus h whole square is equals to plus or minus 4a into y minus k. Okay? Looking like x minus h whole square is equal to plus or minus 4a into y minus k, which represents either upward or downward parabola based on the sign before 4a. On comparing with this, instead of h comma k, we have here minus b by 2a comma 4ac minus b square by 4a. Of course, length of lattice rectum means which is instead of 4a. Instead of 4a is 1 by modulus a. Why I am saying it is modulus? Even though if small a is negative, lattice rectum should not be negative. That's why keeping modulus sign for it. Observe that quadratic function f of x is equal to ax square plus bx plus c always represents either upward parabola or downward parabola with the length of lattice rectum 1 by modulus a. See, if a is increasing, what will be happening? Quadratic expression graph. If a is increasing, 1 by modulus a is decreasing, obviously length of lattice rectum will be decreased, means the width of the parabola will be decreased. Lattice rectum is decreasing means width of the parabola is decreasing. Suppose if small a is decreasing, lattice rectum will be increasing. Lattice rectum is increasing means width of the parabola will be increased. So a cannot be 0, however. So that's why lattice rectum Length of the lattice rectum is always exist for any type of quadratic expression which represents a parabola. So this is length of lattice rectum and this is vertex of the parabola. So now let us see the graph of a parabola. One we can say that it represents upward and downward. If right hand side before Fourier sine is positive, it represents upward parabola. If right hand side before Fourier sine is negative, it represents downward parabola. If it is upward parabola, what are the types? If it is downward parabola, what are the types? Now we are going to discuss. Okay. See, if y is equal to f of x is equal to ax square plus bx plus c, a not equals to 0, can also be expressed in the form of a parabola x minus of minus b by 2a whole square is equal to 1 by a into y minus of 4ac minus b square by 4a. And also observe that vertex minus b by 2a comma 4ac minus b square by 4a. Here right hand side 1 by a decides whether it is negative or positive. Accordingly, the sign of a is negative or positive. Suppose if a greater than 0, right hand side quantity 1 by a is positive, so that it represents upward parabola. Upward parabola means there are three types based on the nature of roots of quadratic equation or based on the nature of discriminant of quadratic expression. Suppose y is equal to ax square plus bx plus c, a greater than 0, b square minus 4ac less than 0. In case of discriminant is negative, roots of quadratic equation are imaginary. But when we say that quadratic equation has real roots, so whenever the graph of quadratic expression intersect the x-axis in two distinct points, those intersection points are called roots of that quadratic equation. If it touches x-axis at only one point, that point is known as equal root of a quadratic equation. If graph is completely lies above x-axis, means it neither touch nor intersect x-axis, we say that quadratic equation has no real roots, because on x-axis we can see only real numbers. Wherever the graph is intersecting, those points are called real roots. Okay, wherever the graph touching x-axis, the point is known as real and equal root of quadratic equation. If graph neither touch nor intersect means completely lies above x-axis, it has no real roots. Observe that b square minus 4ac less than 0 means quadratic equation has imaginary roots. Why it is completely lies above x-axis? Because it is upward parabola. Upward parabola means open curve along y-axis. So it is upward parabola and having imaginary roots. That's why it is completely lies above x-axis. Observe that minus b by 2a comma 4ac minus b square by 4a is its vertex, and this is called lattice rectum. Okay, here to here it is a lattice rectum. As a values are increasing, 1 by a values will be decreased. 1 by a is decreasing means automatically length of lattice rectum is decreasing. Length of lattice rectum is decreasing means curve will be compressed like this. So the width of the parabola will be decreased. If a is decreasing, lattice rectum will be increasing. Automatically width of the parabola will be increased. So width of the parabola depending upon coefficient of x square. And also observe that in this case already a is greater than 0. Now the expression means it is y value. A is greater than 0. Y is nothing but ax square plus bx plus c. Ax square plus bx plus c is also positive for all real values of x. You take any real value on x-axis, corresponding graph is always lies above x-axis, means y is always positive. We say that coefficient of x square small a and the whole expression ax square plus bx plus c will have same signs. Both are positives. Will have same signs for all x belongs to R whenever roots are imaginary. And also observe that the lower boundary of the curve, lower boundary of the graph is y is equals to 4ac minus b square by 4a. Upper boundary does not exist. That's why in case of a is greater than 0, graph is left side decreasing till vertex of a parabola. After that stage onwards it is increasing. So this is increasing, this is decreasing. So left side decreasing, right side increasing means it has minimum value at a certain point. So corresponding x value is minus b by 2a. So graph has, quadratic expression has minimum value at x is equals to minus b by 2a, and that minimum value y is equals to 4ac minus b square by 4a. Okay, let's go to next case. See, our next case, y is equal to ax square plus bx plus c, a greater than 0. Here also coefficient of x square is positive and b square minus 4ac is equals to 0. In case of discriminant is equals to 0, what will be happening? Roots of quadratic equation will be real and equal. Real and equal means graph of a quadratic expression will intersect x-axis in 2 points. Those 2 points will be coincide with each other. So that is the meaning of roots are real. Of course, quadratic equation always will have 2 roots. They may be different, they may be equal. In this case, roots are equal. Means those 2 roots, those 2 values will be coincide with each other. But actually, the vertex of this parabola is minus b by 2a comma 4ac minus b square by 4a. As it is touching x-axis, whose y coordinate will be 0. That's why it can also be written as minus b by 2a comma 0. Observe that lower boundary of the graph is x-axis itself, which is y is equals to 0. In this case, graph has minimum value at minus b by 2a, and that minimum value is 4ac minus b square by 4a. Because of b square minus 4ac is equals to 0, 0 by 4a will be 0, so that its minimum value is 0. Left side of vertex, graph is decreasing. Right side of vertex, graph is increasing. And also, here, coefficient of x square, small a is positive obviously. And observe the graph. Graph is also completely lies above x-axis except vertex. So except this point, graph is completely lies above x-axis. Wherever the graph is above x-axis, that is called expression is positive. At those points, expression is positive. Observe that for all these real values, graph is above x-axis only. For all these real values. But at this particular point, minus b by 2a, graph touching x-axis means its value is 0. After this point again, graph is above x-axis means graph value is positive. So that coefficient of x square small a and the expression ax square plus bx plus c will have same signs for all x belongs to R. For all x belongs to R except minus b by 2a. Why we are writing except minus b by 2a? If minus b by 2a is also included, what will be happening? At the particular point, graph value is 0. It's not positive. It's not negative. So that for all x belongs to R except minus b by 2a, coefficient of x square and expression will have same signs. It has a minimum value. That minimum value is again 4ac minus b square by 4a, and the minimum value is 0. Okay, let's go to next case. See here, third case, y is equal to ax square plus bx plus c, a greater than 0, b square minus 4ac greater than 0. Here a greater than 0 represents graph is upward parabola. b square minus 4ac positive represents quadratic equation has two distinct real roots. Let the roots be alpha and beta. These are real and distinct roots means somewhere on x-axis. Alpha somewhere here, beta somewhere here, for example. So graph is upward parabola. Because of these are roots, definitely graph will intersect x-axis at alpha and beta. So this is the shape of the graph. Whichever the shape, always vertex will be minus b by 2a comma 4ac minus b square by 4a only. Observe that alpha to left side for all x values corresponding f of x values are above x-axis. Beta to right hand side for all x values corresponding y values are above x-axis. Means graph is positive. Graph is positive. For all x values which are lying between alpha and beta, graph is below x-axis means it is negative. See, ax square plus bx plus c is graph. A is a coefficient of x square. Of course, here a is greater than 0. A greater than 0 and expression is also greater than 0. Left side of alpha and right side of beta. Okay. And a is greater than 0, expression is negative means both will have opposite signs in between alpha and beta. Once again, coefficient of x square and the expression will have same signs whenever x does not lies between alpha and beta. Okay. Now, coefficient of x square and the graph both will have opposite signs when x lies between alpha and beta. At alpha, at beta, what will be happening? Coefficient of x square is positive and the expression value will become 0. And also observe that lower boundary of the graph is y is equals to, what is y coordinate of this point? 4ac minus b square by 4a. 4ac minus b square by 4a is lower boundary, and also left side of the vertex graph is decreasing. Till here it is decreasing nature only. Right side of the vertex graph is increasing, so that it has minimum value at x is equals to minus b by 2a, and that minimum value 4ac minus b square by 4a. Okay. See, our next case, depending upon coefficient of x square sign, y is equal to ax square plus bx plus c, a less than 0 along with b square minus 4ac less than 0. Means roots of quadratic equation are imaginary. Roots imaginary means we can't see those roots on x-axis. Because of no imaginary values on x-axis, graph is always neither touch nor intersect x-axis, and small a less than 0, graph of this quadratic expression represents always downward parabola, neither touch nor intersect means graph will be like this. Observe that this completely lies below x-axis because it should neither touch nor intersect. That's why completely lies below x-axis, but vertex is same, minus b by 2a, 4ac minus b square by 4a, and upper boundary of the graph is y is equal to 4ac minus b square by 4a. Lower boundary of the graph does not exist. And also observe that left side of the vertex graph is increasing, right side of the vertex graph is decreasing. Vertex is called turning point of the graph, and left increasing, right decreasing means it is graph has maximum value at this turning point. At turning point, corresponding x value is minus b by 2a and y value is 4ac minus b square by 4a. Means graph has maximum value at x is equals to minus b by 2a, and that maximum value is y is equals to 4ac minus b square by 4a. Okay, this is the next. See, our next case, y is equal to ax square plus bx plus c is a quadratic expression. A less than 0 along with b square minus 4ac is equal to 0. if b square minus 4ac is equals to 0, what will be happening? Roots of a quadratic equation are real and equal. Real and equal means graph definitely touches x-axis at only one point. And a less than 0 represents downward parabola. Means graph is touching x-axis like this. Completely downward parabola. Observe that vertex is minus b by 2a comma 4ac minus b square by 4a. As it touches x-axis, whose y-coordinate must be equals to 0. And left side of the vertex graph is increasing type, and right side of the vertex is graph is decreasing type. Because of that reason, it has maximum value at the vertex. Vertex is called the maximum point of the graph. And upper boundary of the graph is equals to 0. Lower boundary does not exist. That's why its maximum value is 0, that occurs at minus b by 2a. Okay? So this is the nature of the graph. Next. Y is equal to ax square plus bx plus c be a quadratic expression. A less than 0, b square minus 4ac greater than 0. A less than 0 stands for graph is downward parabola. B square minus 4ac greater than 0 means roots are real and distinct. Roots are real and distinct means graph should intersect x-axis in two distinct points. Because of downward parabola, so graph will be like this. Somewhere here alpha. For example, somewhere here alpha, this is beta. Observe that what will be happening. Left side of vertex increasing, right side of vertex decreasing, so that it has a maximum value at the vertex as the above graph. At x is equal to minus b by 2a, it has a maximum value, and that maximum value is y is equal to 4ac minus b square by 4a. Upper boundary exists, lower boundary does not exist. Of course, you see that left side of alpha is graph completely negative, right side of beta is graph completely negative. Between alpha and beta, graph is positive. Of course, see, already we know that a is less than 0, graph is negative, a is negative, graph is negative. Graph and coefficient of x square will have same signs, left side of alpha and right side of beta. Here also they have same signs. And what will be happening between alpha and beta? A is less than 0. Between alpha and beta, graph is above x-axis means it is positive. Both will have opposite signs. At alpha and beta, graph is completely 0. So, this is the nature in this case. So, all the graphs can be seen by drawing at one coordinate system. I will show you now. See, all the graphs related to quadratic expression can be seen only in three cases based on coefficient of x square, sign and their discriminant. See, in case of b square minus 4ac less than 0, b square minus 4ac less than 0 represents roots are imaginary. Roots are imaginary means it is very clear that graph neither touch nor intersect. Neither touch nor intersect graphs in two cases based on sign of small a. If a greater than 0, upward parabola means it completely lies above x-axis. If a less than 0, downward parabola means completely lies below x-axis. B square minus 4ac is equal to 0. A greater than 0 is upward. B square minus 4ac is equal to 0. A less than 0 is downward. Roots are real and distinct means this is for a greater than 0 and b square minus 4ac greater than 0, and down graph will be for a less than 0 and b square minus 4ac greater than 0. And also observe the nature. Whenever graph is upward, it has a minimum value. Graph is downward, it has a maximum value. In case of graph is upward, this is the minimum value. Maximum value does not exist. So that's why for upward graph range is 4ac minus b square by 4a comma infinity. For downward graph range is minus infinity to maximum value. So for downward graph range is minus infinity comma 4ac minus b square by 4a. So this is for upward range. This is for downward range. So this is above range. And also 1-1h. Quadratic function never be 1-1 function because we can draw many lines which are intersecting the graph more than 1 point which is parallel to x-axis. That's why quadratic graph is not 1-1 function. And also left side of vertex it is decreasing, left side of vertex it is increasing. Right side of vertex it is increasing, right side of vertex it is decreasing. So it is throughout the domain don't have either increasing nature or decreasing nature. That's why quadratic function neither increasing nor decreasing. So it is completely positive, it is completely negative. It is positive everywhere except vertex. It is positive everywhere, left side of alpha, right side of beta. And between alpha and beta it is negative, and downward is completely opposite. So it is not a periodic function because graph is not repeating after certain interval. So its periodic nature is not periodic. What about continuity nature? Graph is continuous everywhere on its domain. What is the domain of quadratic function? It is defined everywhere on x-axis. For each and every x value corresponding f of x value exists. That's why graph is defined everywhere so that its domain is R. Domain is R. Ranges are these depending upon either upward or downward. Okay. Continuity nature. It is continuous everywhere on its domain. We can draw the graph without lifting marker from the board either upward or downward. So it don't have any sharp edge or discontinuity points. That's why it is also differentiable everywhere on its domain. Okay. So this is about quadratic functions.